Let's consider machine translation application. For instance, English to French sentence. So basically, machine translator translate one language to another language. If you go to translate.google.com, you can demonstrate the state-of-the-art machine translator. Nowadays, the machine translator very well translate English sentence to French or German, and vice versa. And the main technology nowadays is the neural network. So neural machine translator dominate this domain. Every machine translator nowadays, they always utilize the neural networks. And among many different neural network architecture, nowadays attention-based mechanism becomes the state-of-the-art, and every state-of-the-art algorithms use attention mechanism. So I will explain what is attention mechanism in this video clip. So the sentence of English language usually consists of many different words, right? And French sentence as well. There are many French words. Okay. So when you construct the French sentence have the same meaning with the English sentence here, you have to find the right French word based on the English sentence. And when you find the first French word, you usually focus on the first word of English language. And sometimes some other English word also useful to pick the right French word. The second French sentence maybe depends on the second English word or some last English word in some cases. Okay, so this process very depends on specific corresponding word, right? But the problem is there is no fixed structure. Sometimes these first words very depend on the first word of English sentence. Sometimes the first words very depend on the third word of English sentence. Sometimes this position very depend on this, but sometimes this position very depend on this. There is no fixed correlation. It very depend on sentence, it very depend on location and so on. And very depend on input and very depend on the output. It's very case by case. Okay. So for this property, we can consider attention mechanism, and the key point of attention mechanism is this. Let's consider encoder and decoder structure. Encoder basically abstract all the information of input sentence, in this case English sentence, and decoder construct the output sentence based on the information from encoder. Okay. So because the input sentence is a kind of sequential information, because it consists of many different words, and the position of each word have some very important meaning. We can consider input as some sequential structure, so we can utilize the RNN structure to encode the input English sentence. Each each word go into each position of RNN. And many machine translator actually use bidirectional RNN to encode the input sentence information. And using the encoded information by RNN structure, you can construct the front sentence. Again, the output also some sequential information. You can use some RNN structure to generate some French sentence like this. Okay, when you make the input at each time, you have to look at the input information. Sometimes the first word of English sentence is very important. Sometimes the second and last words is very important. Sometimes this is very important. But we don't know a priori. We have to adaptively learn where we have to look at to generate the current corresponding French word. Okay. To do this, we can consider a kind of attention mechanism. So where basically each time we can generate some query vector. And each encoder position generate two vector called key and value. Okay, so based on the query and key, you can measure the similarity or importance of the input. So you can measure some kind of value, which is a function of some, which can be measured by some function f, where input is query value and the key value. And from the alpha I, so basically you have to compute the alpha I for all key of all input position. And compute the similarity between this query and all different keys. So this similarity alpha I basically measure the importance of each input position to make the current output French word. And using this alpha I, you basically make kind of fully connected operation. So which make a fully connected operation to every value vector here. And combine the information. Value of i's position. So alpha I indicate the importance, which is measured by function f with input query and the key of i's position. And then combine all the value information using this adaptive weight alpha I. So because of this adaptive way, we can essentially bring the nice property of fully connected neural network and the convolution neural network, which can adaptively control the local position or how to generate filter in a very flexible shape using this similarity measure. And here the weight parameter alpha I is very controlled by this function f, which is varied by very dynamical way. So at each time we can focus on very relevant positions to generate the output word. This is very nice, right? So this is the idea of attention mechanism.